How are dozens of quiet engineering breakthroughs transforming the trucks that move nearly everything in the modern economy? 15 million heavy-duty rigs cross the world's freight corridors daily, each burning through 30% of its operating budget on fuel alone. Scale that across 90,000 kilometers per truck per year, and a single percentage point of efficiency reshapes an entire industry worth billions. That's exactly the promise behind smart technologies now taking transport to the next level, from aerodynamic seals cutting drag by 9% to AI systems detecting driver fatigue with 94% accuracy. The hidden engineering keeping the world moving is about to unfold. Every year, more than 24 million heavy-duty trucks roll across highways, ports, and industrial corridors around the world. These are not just machines, they are the backbone of the global economy, each one logging close to 90,000 kilometers annually. Add it up, and the total distance covered by the world's truck fleet reaches into the trillions of kilometers, a number so vast it is hard to imagine, but every kilometer comes with a cost. Fuel alone eats up nearly a third of what it takes to keep a truck on the road. For a fleet manager, that means even a small shift in efficiency, 1% here, 2% there, can mean the difference between red ink and black. A single percentage point of fuel savings does not sound like much until you multiply it across millions of trucks and billions of kilometers. That is why the search for incremental gains is not just a technical exercise. It is a matter of survival for operators facing razor-thin margins. When fuel prices spike or regulations tighten, the pressure lands squarely on the people managing these fleets. Maria Gomez, who oversees operations for a major carrier, puts it plainly, "If you can save me half a liter of diesel per 100 kilometers, I'll find a way to fit it into the budget." The scale of the problem is matched only by the scale of the opportunity. With global freight volumes topping 35 trillion ton-kilometers each year, even a modest improvement in efficiency ripples out, saving billions of liters of diesel and cutting millions of tons of carbon emissions. This is why fleet managers track every drop burned, every hour idling, and every route mile. In an industry where cost and competition never sleep, the margin for error is thin, but the leverage of a smart fix is enormous. That is the real story behind the push for smarter trucks, not a quest for the next big thing, but a relentless drive to squeeze value from every kilometer. And it is why the quiet breakthroughs, those aerodynamic tweaks, loading innovations, and digital tools matter so much. Each one chips away at a massive global problem, turning small ideas into big results. Subscribe and stay with us as we break down the real-world inventions, reshaping how the world's freight gets moved. One percentage point at a time. On any long-haul highway, the wind is a relentless adversary. The gap between a truck's cab and its trailer might look like an afterthought, but at highway speeds, it is a vortex generator, churning up turbulence that saps power and drains fuel. Dr. Kambiz Solari, an aerodynamics engineer at Lawrence Livermore National Laboratory, has spent years in wind tunnels and on test tracks quantifying just how much energy gets lost in that invisible space. His research shows that sealing the cab to trailer gap with flexible fairings or rigid extenders cuts drag by 7 to 9%. That is not a theoretical number. It is backed by full-scale wind tunnel tests and months of field data from North American fleets. The physics are straightforward but unforgiving. Drag force rises with the square of speed, and the power needed to push a truck through the air climbs even faster with the cube. At 90 kilometers per hour, a conventional tractor-trailer can burn an extra 2 liters of diesel per 100 kilometers just to overcome the swirling air behind the cab. But when a gap seal kit is installed, field trials have measured a 4.2% drop in diesel use, saving about 350 liters per truck each year. For a fleet running hundreds of trucks, that translates into tens of thousands of dollars in avoided fuel costs and a payback period that is often less than a year. The retrofit is simple. Most gap seal kits bolt onto existing frames in a few hours and require only routine inspection for wear. The upfront cost, typically between $1,000 and $3,000 per truck, is modest when compared to annual fuel bills. Dr. Solari puts it plainly: closing the cab-to-trailer gap is one of the cheapest aerodynamic upgrades, with a return on investment under 12 months. Even if diesel prices are low, skeptics sometimes worry about handling in crosswinds or added maintenance, but telematics from a 12-month carrier trial showed no measurable increase in sway or vibration, even on exposed stretches of highway. The practical lesson is clear. In the world of heavy-duty trucking, aerodynamic drag is not just a physics problem, it is a business problem that is finally getting solved with off-the-shelf engineering. And as fleets look for every edge, quick mechanical fixes like gap seal kits prove that even small design changes can deliver measurable, repeatable returns. At the heart of every port and distribution yard lies a stubborn bottleneck: the time it takes to get a loaded container off a truck and onto the ground, or vice versa. For decades, the scene barely changed. Forklifts darted between trailers, drivers idled in line, and every minute was a drain on fuel and patience. But at the port of Rotterdam, that script is being rewritten. Automated container handling systems now move 40-foot containers, each weighing up to 30 tons, from trailer to dock in less than 2 minutes. That is not a theoretical claim. Telemetry from a recent Rotterdam pilot logged over 3,400 container moves, with an average unload time of just 1.9 minutes per cycle. The hardware behind this leap is a self-loading trailer equipped with electric actuators and a dual-arm robotic gantry. Instead of waiting for multiple forklifts, a single operator can trigger the system, which grips the container's corner castings, lifts, and slides it onto a rolling platform, all in one seamless motion. The impact ripples through the entire yard. Where a manual process would tie up a truck for 10 minutes or more, automation slashes dwell time by more than 70%. That means trucks spend less time idling, burning less diesel, and turning around faster. Marta Vandenberg, a senior logistics engineer at the port, puts it bluntly: automation of the load and unload step removes the bottleneck that traditionally forces trucks to idle in yards for 30 to 45 minutes. The data backs her up. Since installing the automated system, yard throughput at Rotterdam has jumped by 23%, allowing the terminal to process thousands more containers each month without expanding its footprint. For fleet operators, the gains are tangible: less idle time, lower fuel bills, and tighter delivery windows. For ports, it is a direct path to higher capacity and better reliability. No new land, just smarter machines doing the heavy lifting. These advances in automated handling are more than just mechanical upgrades. They are a blueprint for what is possible when engineering is aimed squarely at the everyday friction points of modern logistics. With dwell time cut to a fraction and throughput up by nearly a quarter, the era of waiting in line is quietly being retired. Big Mike Davis has spent nearly 30 years hauling freight along Interstate 40. The hardest part is not the miles, it is the grind of daily tasks: climbing in and out of the cab, tightening straps, crawling under trailers to check couplers. Each movement, repeated hundreds of times a week, wears down bodies long before engines give out. But new tools are changing the rhythm of the job, easing the strain with every cycle. Securing a load used to mean wrestling each strap by hand, cranking for 30 seconds per bundle multiplied across a dozen straps. Now, with the Rapid Tie pneumatic strap tool, Mike locks down each strap in under 5 seconds every time. The tool applies a steady 2,400 newtons of tension, enough to meet inspection standards, without guesswork or muscle fatigue. For Mike, that is a 12% reduction in loading time and fewer aches at day's end. Across a major grocery fleet, Rapid Tie systems cut total route time by 5% and dropped cargo damage claims by almost 20% over 18 months. Coupling trailers is another pain point. Manual fifth-wheel couplers, especially in bad weather or darkness, slow everything down and put knees and backs at risk. The Wabco automated air ride coupler changes that. With one press inside the cab, the trailer locks or releases in less than 3 seconds, down from the usual 10 to 15 seconds. Field trials showed a 1.9% drop in fuel use, thanks to smoother engagement and less idle time. Drivers reported 15% less coupling-related discomfort, and some routes managed with one fewer crew member. On the dock, Loadmaster's robotic arms pick and place Euro pallets in about 9 seconds, an 80% speed gain over forklifts. For round-the-clock distribution centers, that is a 30% cut in dock congestion and less truck idling. For Mike and his peers, these are not just gadgets. They are time savers, injury reducers, and a way to keep rolling in a business that rarely slows down. Hybrid generator powertrains are changing how heavy trucks handle routes defined by constant stops and starts. Instead of driving the wheels directly, the diesel engine operates at its most efficient speed to generate electricity. That electricity charges a battery that then powers electric motors responsible for moving the truck. This series hybrid setup is no longer just a theoretical improvement. It is producing measurable results in the field. A Scandinavian forestry pilot put Volvo 5NR hybrid trucks to the test over 18 months, hauling timber through steep grades, muddy tracks, and city streets. Telematics data from the trial revealed an average diesel savings of 10.8%, with short-haul runs exceeding 12%. Nitrogen oxide emissions dropped by nearly a third, and on routes under 150 kilometers, electric-only operation covered over 20% of the distance. These figures come directly from operator logs, not lab projections. There are trade-offs. The hybrid's battery and generator add about 1,200 kilograms, reducing payload and forcing tough decisions for haulers, sometimes leaving logs behind. The initial purchase price is higher too, $150,000 versus $120,000 for a standard diesel truck. But when annual fuel costs are factored in, the savings begin to offset the upfront expense. On routes with frequent stops, such as urban deliveries, regional distribution, or logging, the return on investment can arrive within months. Professor Henrik Sondergaard at the Technical University of Denmark has tracked these trucks in real-world conditions. He describes hybridization as the most practical bridge to full electrification for Class 8 trucks, especially where charging infrastructure remains limited. He says you get a double benefit: lower fuel use now and a platform ready for full battery or hydrogen when the time comes. The hybrid generator's flexibility stands out. Fleets can run on diesel, biodiesel, or LNG, while the electric drive smooths power delivery and reduces engine strain. For operators, cutting diesel use by 12% across a fleet quickly adds up. For the freight industry, it is a tangible move toward cleaner, more efficient transport. Long-haul trucking has always demanded sharp focus behind the wheel, but fatigue and distraction remain stubborn risks. In 2023, a new wave of artificial intelligence-powered safety cameras began changing that equation. These systems use computer vision to monitor subtle cues, like eyelid droop, head position, and gaze direction, detecting the earliest signs of drowsiness or inattention before disaster strikes. In a federally monitored field trial, 46 Volvo trucks equipped with these cameras logged over 1 million driving hours. The results were hard to ignore. The artificial intelligence achieved 94% accuracy in spotting microsleeps, and fleets recorded a 30% drop in driver-related incidents compared to trucks without the system. The technology works in real time. When the camera detects a warning sign, such as a driver's eyes closing for just a fraction of a second, it delivers an immediate alert. If risky behavior continues, the system sends a signal to the fleet manager, prompting a check-in or, in some cases, a mandated rest break. Dr. Maya Patel, a senior safety technologist at Massachusetts Institute of Technology's Transportation Research Lab, explains, "The goal is not to police drivers, but to catch the moment when fatigue becomes dangerous. Most incidents are preceded by seconds of inattention that go unnoticed by the human brain, but not by the camera. Privacy concerns have been front and center, especially among drivers wary of constant surveillance. The latest systems address this with edge processing. All videos analyzed locally in the truck, and only anonymized alerts or risk scores are transmitted. No raw video ever leaves the vehicle, and all data is erased after a short retention period." This approach complies with strict data privacy laws in both the US and Europe, and has gone a long way toward winning driver acceptance. The Federal Motor Carrier Safety Administration's trial data shows the impact extends beyond safety. Fleets using artificial intelligence safety cameras saw smoother driving profiles, fewer hard braking events, and even a modest improvement in fuel efficiency. The cameras have become a digital guardian, always watching, never tiring, helping to protect drivers, cargo, and everyone else on the road. As these systems become standard, the margin for human error narrows, and the industry moves one step closer to a future where technology and human skill work seamlessly together. Next, the focus shifts from the cab to the cargo itself, as smart locks and digital tracking take on the challenge of securing the world's freight. Cargo theft remains a stubborn threat along Europe's busiest freight corridors, costing operators billions each year and driving up insurance costs for everyone. But a new generation of internal smart locks paired with GPS and geofencing is quietly rewriting the rules of cargo security. These locks do not just seal the trailer, they report their status in real time, sending alerts if a trailer crosses a digital geofence or moves unexpectedly. In a year-long trial led by a Dutch chemicals distributor and an EU security consortium, fleets equipped with IoT-enabled locks saw theft incidents drop by 45%. The system's battery lasts up to 18 months, and every lock event is logged and time-stamped, creating a digital audit trail that insurers now recognize as a risk reducer. That recognition matters. After 12 months, the distributor's insurance premiums fell by 12%, a direct financial upside for adopting the technology. Sven Jansen, a senior risk analyst at AIG Global Commercial, puts it this way: "Geofencing gives shippers instantaneous visibility, turning a lost trailer scenario into a manageable security event." As these digital locks become standard, the industry is starting to treat cargo security less as a gamble and more as a data-driven, insurable asset, laying the groundwork for the next wave of efficiency technologies. On the cold chain, every degree matters. Refrigerated trailers, reefers, used to run their diesel engines around the clock, burning extra fuel just to keep produce, dairy, or pharmaceuticals at the right temperature. Now, regenerative electric refrigeration units are cutting that fuel bill by a fifth. When a truck breaks, kinetic energy that would have been lost as heat is captured and stored, then fed back into the refrigeration compressor. Over a year, a single Cold Chain Pro unit saves about 4,200 euros in energy costs and reduces carbon dioxide emissions by 0.12 tons per truck. For a fleet, the numbers multiply quickly. Heavy haul is another world of extremes. Transporting wind turbine blades or construction cranes means pushing the limits of what a road can handle. Hydraulic, low-profile trailers now offer 15% more payload capacity than traditional designs, thanks to adjustable frames that conform to each load. Carlos Mendez, a project director moving turbines across the Midwest, explains that these flex-frame trailers eliminate the need for multiple specialized rigs. The result is fewer trips, 8% less fuel used per ton-kilometer, and a simpler logistics chain. Dr. Annika Schmidt, a cold chain analyst, sums up the impact. Regenerative refrigeration is not just about lower bills, It is about reclaiming wasted energy and keeping product integrity high. As specialized trailers and smart reefers become standard, the industry gains the flexibility to move everything from ice cream to 80-ton nacelles with less waste and more control. Platooning is redefining what it means for trucks to travel together. Instead of a loose convoy, modular platforms now allow rigs to run in tightly spaced formations, each truck communicating with its neighbors in real time. With vehicle-to-vehicle links and adaptive cruise systems, the gap between trucks can shrink to just half a second, about 15 meters at highway speed. That small distance matters. When a following truck rides in the aerodynamic slipstream of the leader, drag drops and fuel savings add up fast. A Swedish pilot with 12 trucks on a 300-kilometer highway stretch logged a 6.2% fuel cut for every follower, and even the lead truck saw a modest gain from smoother acceleration. The promise is clear. If fleets can platoon across thousands of kilometers, the savings could reach billions of liters of diesel each year. But the technology is running ahead of the rule book. In most countries, highway codes still forbid gaps this tight, and communication standards remain fragmented. Lars Eriksson, who leads the Swedish program, puts it simply: the hardware works, the fuel data is there. What's missing is the legal green light to unlock the full benefit. As modular, platooning-ready trucks roll off production lines, the industry faces a new kind of challenge, one that isn't solved by engineering alone. Every hour, over 15 million heavy-duty trucks shape the backbone of global trade. The real transformation isn't a single leap, but a series of practical, scalable breakthroughs, each one shaving minutes, liters, and risks from a system that never sleeps. As fleets evolve, small innovations add up to massive impact. The next chapter of transport is being engineered now. For more hidden systems behind the world's movement, subscribe and join the investigation.